This is problem 267 of the textbook. For this one, I went ahead and wrote out the given. So the given, and look at the figure from the book. But they give us F1 is along that negative x-axis. They give us F3, and we don't know the direction of F3 or the magnitude. F2, we know the direction of. They give us the transverse and azimuth angles. And then they tell us in the words that R is 600 pounds along the positive y-axis. They want us to find F3, and they want us to tell them the magnitude and the coordinate direction angles of F3. So I usually just like to start with, what we know. We know F1 plus F2 plus F3 equals R. F1, I'm just going to write out each of these. So F1 equals negative 180I pounds, because it's just along that negative x-axis. F2 equals, it's 300 pounds, and we need to break that into the x and y coordinates. So for the x coordinate, we'll do 300 pounds times cosine of 30 degrees, and that's that F2 prime. And then times sine of 40 degrees, because it's that opposite one we're interested in. And that's the I direction. And then for the J direction, we'll do plus 300 pounds cosine of 30 degrees. So that's that F2 prime again. So that's just getting us down to that XY plane. And then times cosine of 40 degrees. And the cosine is just that adjacent one, so that gets us over the y-axis. And then for the k-axis, it's minus, because we see it's pointed down, and it's 300 pounds times that sine of 30 degrees, because it's the opposite of that 30-degree angle, or that side. So we can go ahead and multiply that out. And if we do that, we get F2 equal to 167I plus 199J minus 150K. And that's all in pounds. So now we have F1, we have F2. F3, we don't really know anything about, but we can go ahead and write what we do know, or how we can represent it. F3 equals F3 cosine alpha I plus F3 cosine beta J plus F3 cosine gamma K. And then we also know the R equals 600J. That's pounds. So now we know, now we have all of these written out. And so what we can do now is we can just pull out all the I, J, and K components to solve for each of these. So we'll start with the I. So I'm going to pick a different color. So if we pull out the I components, we're basically just pulling the I components from this formula up here, that F1 plus F2 plus F3 equals R. So F1 is negative 180 in the I direction. F2 is 167, so plus 167. F3 is plus F3 cosine of alpha, and that equals 0, because R doesn't have anything in the I direction. And so we can reduce this just to make it easier to deal with it later. F3 cosine of alpha equals 180 minus 167, which is going to be 13. So I'm going to highlight that, maybe go with a different color. And then we're going to pull out the J components. So we'll do the same thing with the J components. F1, there's no J component. F2, we have 199. F3, we have that plus F3 cosine beta in the J direction. and then that equals 600, because that's all in the j direction. So we can reduce that to F3 cosine beta equals the 600 minus 199. That equals 401. So that's our second equation. And now let's pull out the k components. F1 doesn't have anything in the k. F2 has negative 150 in the k. F3 is plus F3 cosine of gamma is in the k, and that equals 0 because there's no k component of r. So F3 cosine of gamma equals 150. So we have three equations with three unknowns. So we're not going to quite be able to get to the answer yet. So we know we can, or we know an equation, we know cosine, we know cosine, we know a relationship between alpha, beta, and gamma. Cosine squared alpha plus cosine squared beta plus cosine squared gamma equals 1. So that gives us basically a fourth equation. So if we have four equations, we have four unknowns, we can solve that now. So let's pull these. So we have cosine of alpha. If we just rearrange that, it's equals 13 over F3. So 13 over F3 is cosine of alpha squared, plus for cosine of beta is going to be 401 over F3 squared, and then cosine of gamma is going to equal 150 over F3, and that's squared, and that equals 1. So now we can multiply that out. So we can pull the F3 squared over to the right side. So this equals F3 squared. We can take that 13 squared plus 401 squared plus 150 squared, and we get 183,470. And now we can just take the square root of both sides. And so we get F3 equals 428 pounds. So that's the magnitude of F3. And then we also want to go ahead and get those alpha, beta, and gamma. And so from our equations up here, we know cosine of alpha, or F3 times cosine of alpha equals 13. So we can rearrange that to where alpha equals 13 over F3. Move this over. It's the cosine inverse of 13 over F3. So it's just rearranging this formula here. And so alpha is the cosine inverse of 13 over 428. And that gives us 88.3 degrees equals the alpha. Beta, we can do similarly. It's the inverse cosine of 401 over F3. So that's the inverse cosine of 401 over 428. And that'll give us 20.5 degrees. That's our beta. And then for the gamma, gamma equals the cosine inverse of 150 over F3. So cosine inverse of 150 over 428. That equals 69.5 degrees, which equals gamma. So now we have the magnitude of F3, and we have alpha, beta, and gamma. And I'm just going to highlight those so they're easy to see. So alpha, beta, gamma, and F3. And then we'll go back up and look at the problem one more time. So they asked us to find the magnitude of F3, alpha, beta, and gamma. So we're all set.